Hey guys, welcome back to chapter 11. In this video, we are going to work through an example of boiling point elevation, I believe. Yep, boiling point elevation. So here's our question. Calculate the new boiling point of a solution made by dissolving 10 grams of sodium chloride in 54 grams of water. If you would like to challenge yourself and try this, go ahead and pause the video, work it out. If not, I will work it out with you. All right, so we have our boiling point elevation question. So the formula for boiling point elevation looks as follows. I think I move these variables around in every example. It doesn't really matter what order they're in. So we are calculating the new boiling point. We'll talk a little bit more about that statement in just a moment. So that means that we must know Van Hoff, we must know the constant, and we must know molality. So I'm going to click forward on a slide and take inventory of what I know. So I know exactly what I'm dealing with here. So this is what we're solving for. I must have access to these in some way. So first, looking at Van Hoff we got to figure out what our solvent is. So we're dissolving sodium chloride in water. So our solvent is sodium chloride. Is that an ionic compound? Yeah, it is. So we know ionic compounds will dissociate or break apart in solution. So now we need to decide how many particles that's going to dissociate into. So sodium chloride is going to be sodium and chlorine. So the Van Hoff factor here is 2. So I'm going to go ahead and plug that in. On your exam, you will be given a chart very similar to this one. So it'll be up to you to make sure that you are using it correctly. So in this case, we're looking for our KB value, right? So boiling point elevation, we're looking for KB. So we're going to live somewhere in here in our chart. Now we need to decide what is our solvent for this problem. So we're dissolving sodium chloride in water. So water is our solvent. So now we just need to look for water, find the KB value, and it's 0.512 with those crazy units. So 0.5 degrees Celsius over molar. I did not mention this before. I should have in the other video, but the Van Hoff factor is unitless. So it's a value for moles over moles. Those cancel out. So it's a unitless number. So there's no units to keep track of for that guy. All right, lastly, we need to determine molality. So we are not given molality directly in this problem, but we certainly have enough information to solve for it. Okay, so this one's going to take a little bit of work over here. So remember, molality is going to be moles of solute over kilograms of solvent. So our solute in this case is sodium chloride. Of course, it doesn't give it to us in moles. It gives it to us in grams. So we just have to do a quick grams to moles conversion to get that top number. So 10.0 grams of sodium chloride. Got grams on the bottom, moles on top. 1 mole. Grab my calculator. I'm now looking at a periodic table to determine the molar mass of sodium chloride. So sodium is 22.990 and chlorine is 35.453. So the molar mass of sodium chloride is 58.443. So multiply across the top, divide by the bottom. So 10 times 1 divided by 58.443, and we get 0.171 moles. So that's going to be the value that goes on, not a word, a number. So that's going to be a value that goes up here. All right, on the bottom is kilograms of our solvent. In this problem, it doesn't give us kilograms of solvent. It gives us grams of water, but an easy grams to kilograms conversion, and we'll get that number. So we've got 54 grams on bottom, kilograms on top. And in 1 kilogram, there's 1,000 grams. If you can do this in your head, that's absolutely fine. I just kind of wanted to show you the math behind it. So moving that decimal place over 3, we get 0.054 kilograms. So now we have it in our equation. We just need to plug it into our calculator. So I've got 0.171 divided by 0.054. So the molality of this solution is a 3.17 molal solution. All right, so now I have my 3 variables. I can plug them into my temperature change equation and chug through it. So I'm just going to clean my working side of the slide. All right. So to calculate the change in the boiling point, we are going to take Van Hoff, which is 2, times the boiling point constant, 0.512 degrees Celsius, times the molality, which is 3.17. Looking at our units here, this is where that funky unit is useful. So I've got molality on the bottom. I've got molality on the top. The only unit that's left is degrees Celsius. And that's helpful because we are solving for a temperature value. And we would expect that unit to be degrees Celsius. All right, so I'm going to plug these numbers in. So 2 times 0.512 times 3.17. And I get a value of 3.42. All right, so that is how we calculate this change in temperature of the boiling. But we're not done with this problem yet, okay? This problem, and you got to be very careful. It might just say calculate the change in temperature, then you would be done. But this particular problem asks us for the new boiling point. So the boiling point of water has changed. Now we need to calculate that new boiling point. So here's where this chart is also helpful, right? So if you didn't remember the boiling point of water, or we use some other compound that you don't know the boiling point of, we come to this table and we see, okay, the boiling point for water is 100 degrees Celsius. Now that boiling point has changed by 3.42 degrees. It's up to me to decide, am I adding that 3 degrees or am I subtracting that 3 degrees? So go back to the name, boiling point elevation. The boiling point is going to be a higher value. So to get all of the points for this problem, you would need to take that 100 degrees Celsius, which was the original boiling point, plus the change in temperature, which is 3.42 degrees Celsius. So the answer to this problem, the new boiling point for this solution, is going to be 103.42 degrees Celsius. Okay? So be very careful with these problems. Read carefully. Am I just asking for the change in temperature, or am I asking for a whole new boiling point or a whole new freezing point, and take it one step further? That's it for this one. I hope you guys found that helpful.